Welcome everyone to our second meetup for our AI Evals community. Super excited today to have Mike. And yeah, for those of you who don't know, alphaXiv started approximately a year ago, kind of with the goal of like creating more community and discussion on research. And now it's evolved to offer a lot of tools for people sifting through and kind of managing the fire hose of AI research that we see today, as well as a lot of tools to kind of better read and understand papers. And community is something we're very passionate about. So we have our AI for Science community, and recently Vals created our AI Evals community. So yeah, very excited to have Mike here today.
Great. Yeah.
Uh,
Hi, everyone. Oh,
yep. Just to set the stage for the talk will be around 30 minutes, and then we'll have Q&A. If at any point you feel you have burning questions, feel free to put them in the Q&A section. It's going to be at the bottom of the Zoom, and I'll be monitoring that and bring up any burning questions to Mike. But we'll also have a Q&A session at the end. Yeah, really excited. Just do a brief intro. Mike is a postdoctoral researcher at Stanford CS, and he works on empirical evaluations of reasoning LLMs, among many other things. And yeah, previously he's been a researcher at Google Research, ML research at Apple Health, and his work has also touched time series data and code generation. And recently, he's been working on building better data sets for training reasoning models. And today, he's going to be talking about Terminal Bench, which is an open source benchmark for evaluating AI agents in terminal environments. And he's also going to share some of his broader perspectives and maybe hot takes on evals. So yeah, with that, take it away, Mike.
yeah. Thanks so much for the introduction. Hi there, everyone. I'll just say, first of all, please feel free to jump in with questions and send those into the chat, and maybe you guys can manage that and let me know if anything comes up. I think the best talks are ones that are sort of interactive, and I'm happy to be interrupted. So, no worries about that. But yeah, so I'm Mike Merrill. Thanks for the introduction. I'm a postdoc at Stanford, and I'm going to talk with you guys a little bit today about Terminal Bench, which is our benchmark for language models as agents in realistic and hard terminal environments. So sort of just to give like an overview of the talk, I'm going to talk a little bit about why I think evals are so exciting and why I think now is a really crucial time to work on evals. Then I'll talk about Terminal Bench, which is my recent work, and I'll give a preview of what's next for the project and what we're really excited about. And then just at the end there, I'm going to touch on what I think will be important topics for the next 5 years of evals. So why work on evals now? Why is now an exciting time to work on evals? And I think that's because we're in the middle of this transition of language model evaluation, where if you go back a few years to what feels like ancient history, we were very concerned about what does an AI know? And you have benchmarks like MMLU that really set the stage here. So at the time, we were very interested in comparing inputs and outputs, asking questions, and then getting responses from language models. We had very well-defined criteria that we had for success. Can our language models score well on this multiple choice question error? And this all operated under single terms. So these are your kind of classic language model evals. And over the last few years, I think really starting around the time that SweBench came out, we started asking questions of, instead of what does an AI know, but what can an AI actually do? These models became good enough that they can be deployed in real world situations. They became incredibly powerful. I'm sure that I don't need to go into too much detail about why that's the case. But we started to care much more about what are the actions that these models can do? If we take our language model and we put it into an agentic harness, which has many definitions, but for the sake of this talk, let's just consider it to be a language model in a while loop. And we're in a very interesting frontier where we don't have these well-defined success criteria anymore. We maybe have more ambiguity over what a successful action for a model looks like. And we're evaluating models in this interactive multi-turn setting. And I think that this is particularly important because, as some great work from Meter has shown, the time horizon and not just the complexity of these language models and the tasks that they can actually complete has dramatically increased. So, even just going back a few years, you were looking at agents in the GPT-4 era that could only operate on tasks that took on the order of a few minutes for a language model to complete. But now we're starting to see the scaling really take off, where agents are able to complete tasks that take, hours instead of minutes. And you're seeing information from how language models are evaluated on model cards that, like, the frontier labs are really starting to think, like, what are problems that we can put language models into where they have to think on the order of days and not just hours? What are, like, really long horizon, complicated, valuable tasks that agents can do? Um, and so this is what kind of brings us to the terminal, or computer use environments in general, and why I think they're a very exciting thing to work on. So part of what makes the terminal great as a place to understand language models is that it's text-based. So it's in the modality that still works best with language models. For purposes of this talk, when I talk about computer use, I'm going to be talking about text-based computer use. We're not going to be talking about, like, moving a cursor around and clicking on GUI elements. Instead, we're just going to be talking about issuing bash commands and writing code to operate the computer. And this is a very powerful paradigm too. You know, Almost any task that you'd like to do on a computer can be done through the terminal or a similar environment. You can write code to control a computer, you can write bash commands, you can make API calls, you can interact with the web, and it's this very useful abstraction for getting language models and jacking them into compute. Um, and the terminal is also incredibly valuable. It's used by experts, not just software engineers, but systems administrators, scientists, uh, computer security researchers, to do real valuable work that people are paying money for right now. Uh, and all of these things combined make it a very useful place to test the frontier capabilities of language models and agents. And so, just to demonstrate that, I want to say we all know an engineer who works a little something like this. So while you're spending half an hour clicking through your AWS interface to configure an EC2 instance, you're picking the right security group, you're selecting the right instance, maybe you're associating an S3 bucket or some elastic storage with your instance. There's just a single command that does this. And if you know that command, you can get this work done in a fraction of a time. Another example of this is text editing. We've all heard about these, like, legendary cracked ICs who do all their work inside the terminal and only work in Vim and know every macro and know how to get work done in a fraction of the time. And so, like, one of the core ideas behind Terminal Bench was, what if we can build AI agents that work like our best engineers? Instead of doing this clicking and dragging, we just operate a computer entirely through text. And something that we've seen, even since Terminal Bench was initially released back in March, is that to some extent, like, these agents already do. you know so virtually every frontier lab, I think at this point every frontier lab has launched some sort of a terminal agent to help developers do work. um, and something that I think is really interesting is that these workflows haven't just been software engineering. If you go on Twitter, you can find stories of people using Claude Code to manage their email, for example, or to act as a personal assistant. And again, this is because, like, the bash shell and the terminal environment are a very powerful place for agents to work. And you're also seeing this from, your personal assistant agents like Manus that issue bash commands, Codex, and Cursor. Well, they're not purely terminal agents, like, do issue all kinds of very complicated bash commands to get work done. And so, like, we're seeing the terminal becoming this very useful, very powerful interface for language models and computers. And this is a tweet from Guillermo Rauch just a little while ago saying that it's 2025 and some of the most impactful products in the world are command line interfaces. Like, ChatGPT solves problems by writing scripts that execute inside virtual computers. And so, like, we're really seeing this take off as being one of the primary ways that language models do this interaction. Um, But like, do we really know that these terminal agents are ready for hard production environments? Like an example of this is a command like this one. You really wouldn't want Claude Code to execute a command like this in your root system directory and cause all kinds of problems for you. And so to study the capabilities of these agents and indeed to study kind of like the frontier of computer use through text, we built Terminal Bench. Um, so starting off to just kind of talk about Terminal Bench as a data set, like what's actually in Terminal Bench 0.1.1. And this is the Terminal Bench that maybe you've seen on some model cards. You guys at Vals have used a version of Terminal Bench 0.1.1, and it's 80 tasks, each written by a real human, usually a PhD level contributor to our project, who provides a verified ground truth solution to their problem, a set of test cases, and a unique Dockerized environment. And so, like, this is a benchmark that doesn't just come with inputs and outputs in the way that SweBench does. It's a benchmark that comes with full environments, each one unique to the task that it's meant to represent. And just to give you a sense of what some of these tasks look like, we have some that include compiling exotic code from source, like building the entire Linux kernel, scientific computing workflows, like assembling DNA for synthesis, end-to-end data processing, and this is kind of a trivial example that most language models can solve now, but your dreaded broken Python environment that I'm sure we've all struggled with at one time or another. I guess before UV came out and kind of solved this for a lot of people, but it's still something that people definitely struggle with. So I've told you what the data set is. Let's talk a little bit about how a terminal bench task actually works. So as I've mentioned, we have these components which are all created by our wonderful community of contributors where they specify a task, in this case, re-implementing a COBOL program and porting it to a more modern language. And they provide a set of tests which execute inside the container to tell us if the agent has actually done its job, as well as a solution file. And the solution is very important because it means that our benchmark is verified in the same way that SweBench verified is. Like we know that if a human sits down, they can actually complete this task, and it's possible and it's fair to look at how agents do on these problems. And 100% is the highest score that an agent can possibly get on the benchmark. And so, why did we make these decisions? Why is the benchmark structured the way that it does? And that's because we have these core principles that we built into designing Terminal Bench. And those are that we should make it as hard as we reasonably can. The state of the art on it right now, depending on which flavor of the benchmark you look at and how you measure it, is about 50%. We made it real. So every problem in Terminal Bench is something that a person would actually do. And particularly something that we're focused on right now is it's a problem that somebody would actually get paid to do. And so we know that if agents do well on the benchmark, they're actually doing tasks that are valuable to the economy. They also come from PhD level contributors. So we know that these are like things that are hard for humans and not just the types of tasks that you might do day to day inside the terminal, like renaming directories or changing permissions or moving things around or issuing a curl command. And we also built it to be live. So I've mentioned like Terminal Bench 0.1.1 is the common version of the data set that's been released out into the wild, and we're seeing, some model makers pick up on. But we also have plans that I'll touch on in a moment to release subsequent versions of the benchmark that allow it to evolve with model capabilities. Importantly here, it's also version, meaning that if you're a researcher and you want to run Terminal Bench, you have a specific version of the benchmark and you can make scores comparable. And we're frankly really proud of it. I think our community has done a great job putting this together. 3 days after it was released, we were on the Claude 4 model card and they set a new state of the art. And we've seen it on subsequent Claude model cards since then. It's been on the GLM model cards, been on the Kimi model cards. It's been referenced by most of the frontier labs. And so we're starting to see it become, I think, like a real standard for how agents are evaluated. And here's a slide here where I'm just going to talk a little bit about what like the state of the art on terminal bench is right now. This is on a version of the benchmark that we may not release. We're waiting for Terminal Bench 2, which I'll talk about more in a minute. But the best models on Terminal Bench are still scoring less than 50%. And so, you're seeing like really great performance from GPT-5 with Codex, strong performance from like Claude Opus using open hands, and also like pretty low performance from some otherwise relatively capable open source models like GPT OSS. So there's a lot of room for improvement still available here. And we're excited to kind of see how this evolves over time. So this is kind of the state of the art of the project. I am kind of curious if people have any questions. I can pause for a minute if anything's come up.
I think there's one question from Jacob, if you want to go ahead and ask.
Yeah, I don't know if you have an answer. I think a guess would be just as valuable. I suspect 4.5 Sonnet on Claude Code would do quite well in this. Do you have a number there, or can you guess one given other results?
Yeah, I don't think we actually. So this is actually a paper from our iClear submission. But if you look at our leaderboard right now on our website, it looks like 4.5 we've evaluated with our internal agent Terminus 2, and that gets about 50% on the public version of the benchmark. So it is a very capable model, and through some other like closed source agents, you're starting to see performance of closer to like 57%. But there's still a pretty large gap here. There's still a huge set of problems that remain unsolved in the current iteration.
Awesome. I think there's another question from Daryl. Are you able to unmute?
Yes. Do you have confidence in today's LLMs or frontier AI agents to not be in virtual environments or virtual machines due to IP or potentially having the agent go wrong or go rogue? Or is it still best practice to keep the agent or the large language model in that virtual environment
I think
when it
it
comes to terminology?
depends. I think it depends like how sensitive you are to the risks. I mean, I'm running Claude Code on my local machine all the time. It's running right now. And certainly if like you're in a sensitive situation, or I don't know, like God forbid, you're not versioning your code, like you're going to want to keep that thing isolated. But yeah, it's a risk tolerance question. They're quite capable, and they seem to have been RL'd to not make particularly destructive actions. But they also certainly don't give up. I've actually got an example of that in a second. But yeah, good question. So just a couple of things that we've noticed from running the benchmark and looking at models is that GPT-5, for example, all of these agents and all of these models have very different characteristics. And so, for example, like GPT-5 loves to use Nano, and it's not particularly good at it. It's also quite bad at writing JSON, and so it'll mess up API calls and will do much better if it tries to structure its data in other means. And then there's some other weird quirks like Goose, which is one of the open source agents that we support, acts a lot like a senior software engineer. So, maybe we have AGI already, and tries really hard to get you to implement things instead of going off and doing it for itself. And here's actually an example, I think, of GPT-5 where we've tasked it with building the Linux kernel from source. And you can see here that it's entered into a nano session, and it doesn't actually know how to use it. And so what it does is start to panic and try to kill its session, but it's not issuing the commands correctly. And you can see that it starts to kind of panic So it starts hitting Control X, Control X, Control X, Control X again and again and again, and spamming that. Again, maybe like I would do if I found that I was stuck in an environment like this. And so there are like these relatively pedestrian failure modes that the models and agents are still hitting on some of these tasks. And I think actually, if we play this forward a little bit, it'll just keep trying to do that. Yeah, there you go. I mean, it really doesn't know what it's doing in this case. Yeah, again. So what's actually like working on Terminal Bench right now? You know, where are we seeing the frontier really get pushed? One thing that I think is really interesting that you'll see in common if you look at some of the highest performing models on our benchmark right now is that they use something which we've seen called model alloys, where they're actually dispatching calls to many different models throughout the course of the trajectory. So, you know, maybe your initial call will be to Club 4.5 Sonnet, but then it'll randomly shift calls off to other models like GPT-5. And this isn't just a combination of models for the sake of saving money or like using one particular model for planning and another for dispatching commands, but actually something that seems to like empirically increase performance by as much as 7% is just randomly dispatching actions to different models, which is kind of cool. I mean, it's sort of an ensembling method. You know, you can take these language models and stick them together and dispatch different commands between them and actually see like significant gains. Um, the other thing that's obviously very much pushing performance, and I think we're most excited about, is just better models coming out. You know, like with each subsequent model release, obviously performance on Terminal Bench is creeping up. And personally, I'm much more interested in this than I am in changes with the same model and different agent scaffoldings. Because I think that this is like a real reflection of intelligence and how we're probably going to see performance get pushed in the future. Um, and I think the third thing that seems to make a big difference on the benchmark is adapting scaffolds to allow the agent to help itself get unstuck. So, like an example of this is in our agent, Terminus 2, we have this clause where every time that the agent submits a command, it can predict how long it thinks the command is going to have to run. And then if the command is running for longer than that timeout it's specified, it'll give up and try something else. And this really helps in situations where it issues some long-running command and would otherwise just be stuck waiting around, waiting for things to finish. So this also seems to make a big difference. So that's Terminal Bench. I think now what I'll just do is share a little bit of context about what we're hoping to build and what we're excited about as a community. The first thing is that we want to build more hard, high quality tasks. And this will culminate in the release of Terminal Bench 2, which we're putting out as an alpha release at the end of the month. And this will be 100 even harder tasks that are very carefully verified. So something we've spent a ton of time on over the last few months has been like manually looking through every single task that's been submitted to our project and then trying to see if there's ways that the agent can cheat on these tasks. And maybe later I can go into a bit more detail about that. But we do have Terminal Bench 2 coming, and we're very excited to release that at the end of the month. The other thing that we've been working on is a major refactor of Terminal Bench. So something that I think was a bit confusing at the beginning is we wanted to release Terminal Bench to benchmark, but we're also very curious about like what are good systems for running these evals, and in particular, how can we dispatch thousands of evals at the same time? So like one limitation of the current Terminal Bench repo is if you go to run it, it only works on Docker on a single machine. But we're releasing a new project also at the end of the month, which will be the primary harness for running Terminal Bench 2, where we support this like asynchronous, massively parallel deployment. And so in our own experiments, we've been able to run thousands of tasks in parallel through sandbox providers like Daytona. And we're going to make this much easier. We are hoping that sandboxes will become like the default for running these agentic evals, not just of Terminal Bench, but through the 30 or so other benchmarks that we've refactored to run inside the harness. And so this is just something to look forward to, and I want to like tease a little bit now. Actually, if you want to go take a look at it, you can. We made it public. It's just in alpha. It's on the Law Institute GitHub where Terminal Bench is hosted. And if anyone on this call has feedback on that, please hop into our Discord and give it to us. But we want to be like the one-stop shop for running agentic evals. And the third thing we're very excited about is some work on using these environments, not just for evals, but also for training. So something that's very nice about an eval environment is that if you kick your logits back out of the environment as well, you can also use these environments for doing RL on the combination of models and agents. And we have another open source project called DC Agent, which is looking into this and is going to try to answer questions like, how do we build synthetic environments? How do we get the performance of smaller open source models up to par with the larger API models? And we're just kicking this off right now. So if this is something that you're also excited about, you can look into it through our Discord, and we're happy to get you onboarded there. Cool. So that's sort of why I think evals are exciting, what Terminal Bench is, and then a little bit of a sneak peek of what we're working on. I have a couple of slides here, so I actually just threw together for this talk, but something I want to talk about is like, what's actually next for evals? What do evals look like in an AGI world? And so if you've done work in evals before, you've seen plots like this. I know you guys at Vals have plots like this, where you're looking at the Pareto frontier of cost and model performance. And so this is something from our iClear submission, which should be going up in archive also at the end of the month. And you can see here that if you spend more money on running the benchmark, you actually see increased performance. And this is very nice. You get this nice Pareto frontier. You can kind of make these decisions about like, how much do I care about performance versus cost? But I think like what we're really going to be seeing over the next years are plots that look a little bit more like this. So we're going to be looking at the cost of running an agent and actually the amount of money that the agent makes for you. Because as we develop better and better models, it's going to become more and more feasible to deploy these in real environments where they can interact with long horizon tasks and all kinds of end tail behavior that might actually trip them up. And you've started to see this a little bit. So this great blog post came out from Anthropic back in June. Maybe you saw this on Twitter, where they took Claude and they put it in charge of a vending machine in the Anthropic office, and all kinds of wacky hijinks ensued. But this is actually something that you can do right now too. I don't know these vendors very well, but you can go out and buy a vending machine that has a language model integrated in it to help make decisions about inventory and ordering. And I'm actually very curious about like what happens if you take these language models and you put them in these like real deployed environments. Like something I really want to work on, and if anyone has any leads on this, is what actually happens if you take a language model and you put it in charge of a coffee shop. Like I have a friend who owns a coffee shop, and things go wrong all the time. It's not just exiting your nano session. It's like, one of my employees didn't show up today. What am I going to do? Or the walk-in is broken. How can I get somebody in here in time to fix it so that I can open? And I think that like the weaknesses and also the opportunities of language models are going to become more and more evident when we start putting them into these realistic scenarios. Or I don't know, maybe you could, hook one into your E-Trade account or your Robinhood account and let it price trades and see what happens. And I do think that this is the primary way that language models are going to be evaluated in the next few years. So that's most of my talk. I just wanted to give a quick shout out to the team that's made this happen. This is a very small snapshot of all of the people who have worked on Terminal Bench and who have contributed tasks and helped us build our infrastructure. There's about 1,000 people in our Discord now, and there's plenty of work to be done. And so if you're excited about Terminal Bench and would love to help us on any of these projects that I mentioned, we'd love to see you there. And you can find out more about that at tbench.ai or by using this QR code. So that's what I have so far for the scheduled programming. I'm happy to take any questions and dive into things a little bit more now.
Cool. Awesome. Well, there are a bunch of questions. So maybe I can call out people, and if you could unmute yourself and ask the question, that would be great. So I see a question from Monica. Monica, are you able to unmute?
Looks like she answered her own question, so why don't we move on to something else?
Okay. Jacob, are you able to unmute yourself? Okay, maybe I can
Testing 1,
ask.
2, 3.
Cool.
Yes,
Awesome.
that worked. Go ahead, Jacob.
Go ahead.
I asked a few questions. Should you?
I see the one about like higher throughput with sandboxes.
Yeah. Why do you want to parallelize this? I assume the answer is so we can train on it and things like it.
Yeah. I mean, parallelization that is certainly important for training. You know, it's like very difficult to get signal if you're just running like a handful of sandboxes locally. It also just makes it much easier to play well with most clusters which don't support Docker, or many don't. I mean, just like practically speaking, this is important for us because when we're running experiments like the ones we do for our papers or our blog posts, like, you know, you have N models, you have M agents, you know, you have K tasks, and you want to run the benchmark several times. And so, you know, for our recent iClear submission, you know, we ran like probably 30,000 experiments, and you just can't do this locally. So it is important to have some sort of deployed infrastructure to make this possible. For training, this starts to get actually very complicated because you start getting into like an off policy regime and like things get complicated very quickly. But just as a practical, like it's just not practical to run these evals locally on a single machine anymore. Um, for example, like we support running SweBench, and that's 500 tasks, and you just can't do that if you're running it locally. I mean, you can for a single agent and model, but you have to leave your laptop open the whole time, and like things get kind of tricky.
I have a quick question, and then looks like we also have some in the chat. So, Kason can go after that. But I noticed you had a plot for meter, which had a y-axis of time by human. I know in Terminal Bench you normalize by amount of time, like model time. When we hosted Terminal Bench, we actually chose to normalize by number of steps. And then there's some reasons for that. But I'm curious to hear from you what you think the right normalization factor is when we look at some of these tasks.
Yeah, I think that's a great question. So I guess just to start off with, when you're designing an agent benchmark, you need to have some way of telling your agent to call it quits. You know, like agents really don't want to give up. They've been RL'd not to give up. And I think like one codex run that we had in particular used 100 million tokens to try to solve one task and wasn't getting anywhere. So you want to be able to cut it off at some point. There's a few ways you can do this. You know, you can give it a maximum number of steps, as you guys did. That's a good option. You can also look at the number of tokens that the model is producing and give it some sort of like arbitrary cutoff. That's also a good option. The reason that we decided not to use those and instead go with a timeout for each task is that we wanted the benchmark to be compatible with arbitrary agents. And so, you know, if you're running like Claude Code or Codex CLI inside one of these containers, there's quite a great deal of plumbing that has to go into getting these signals back out of the agent. You know, like knowing live at any given point in execution how many tokens Codex is using, I don't think is even possible. Maybe it is for Codex, but it isn't for other agents. They'll only report this information when they're done running. And so it's just not like feasible to like do this with arbitrary agents. The timeouts have been a real sticking point with Terminal Bench. I think when we designed the benchmark originally, we had like the default timeout was on the order of 5 minutes. And this is time for the agent to do its task, not time for the human to do its task, obviously. And we did see that this like artificially hampered model performance. In particular, if you have a very slow API, you can spend a lot of time just going back and forth trying to get your response. And this means that your agent will time out, even if it's on its way towards solving it. And we've tried to address this in Terminal Bench 2.0 by just dramatically increasing timeouts across the board. Like this was probably one of the number one bits of feedback that we got from the community was that the timeouts were too low. And I think that particularly if we are dealing with these longer horizon, longer context tasks, we want to be able to let the agent run for a very long time. So yeah, it's a good question. I mean, I guess just to summarize, the reason that it is the way that it is in Terminal Bench is that it's just not practical to extract this information from like an arbitrary agent. And we wanted to make sure that our harness was compatible with anything you would throw at it, and also easy for people to run.
Right. Okay, that makes sense. Yeah, I didn't factor into the Cloud Code or Codex compatibility concern. Makes a lot of sense. All right, Kaysen, do you want to ask your question?
Yeah, sure. This might be a dumb question, but what prevents like foundational model companies from training and optimizing their models to perform well on these benchmarks?
Yeah, nothing, frankly. I mean, this is a risk with any benchmark, right? Like Sweetbench Verified is just available online. If you really wanted to, you could go ahead and train your model on it. I mean, in practice, we've seen a lot of care taken from the frontier labs to decontaminate their data sets before running models on them. Like in our conversations with Anthropic and OpenAI and the Chinese labs, like they really do care about taking this seriously. I think the real way to measure cheating would be to have a private test set that we don't release. But given the amount of time that's gone into developing these tasks for the public version of the data set, it just wasn't practical to create a private test set. There's also like this question of velocity of your benchmark. I think when you're designing a benchmark, you really do want to make it possible for people to run it easily. And like having this be out in the open, allowing people to look at all the tasks to understand where their model's failing, where it's not, is something to be concerned about. I mean, I think in general, if you look at like the history of benchmarks, so something my postdoc advisor Ludwig Schmidt did during his postdoc was this great paper called something like "Do Models Trained on ImageNet Generalize to ImageNet?" And what he did there is he went and created an entirely new version of ImageNet by following the same recipe that the original authors did to scrape photos with the same categories. And he set out to make that benchmark hoping that he would show that when models are optimized on a public benchmark, they don't actually generalize to a new one, but they really do, And I think similarly, like if you look at Sweetbench and the history of Sweetbench, it's been public, there's this risk of contamination, and certainly the model makers have hill climbed on Sweetbench very aggressively. But there's no doubt that the software engineering agents have gotten better. And so I think like if there was like real money at stake here and we were worried about people like training their own models and submitting them and cheating, like if this were a Kaggle competition, then I'd be much more worried about having a private test set. But ultimately our goal is to improve the state of the art and to move the field forward. And so I think that it's like worth the risk of contamination to make this easy for people to run and for the models to get better. We do have some features, like we have the big bench canary string embedded in every single file in the repo. And so it's super easy to decontaminate if you are training the model. But we don't protect against this kind of like adversarial cheating. But I also don't think that like anyone who would adversarially train a model to do well on Terminal Bench would build a good model. And it probably wouldn't be at the top of the leaderboard either. So I'm not too concerned.
Cool. I see a question from Daryl. Daryl, do you want to unmute yourself and ask the question?
Yes, thank you so much. So have you used Terminal Bench to measure metrics against rogue agents such as an agent instructed to say no, always disagrees with you, a browser agent that opens up websites that are violent, and just an agent that will influence you without you knowing. Have you guys done metrics around those types of areas?
Well, we don't directly test this. Something that I think is great about the terminal bench format is it would be very easy to create a test, like a task that did measure something like this. One thing that we have done is and this was part of our process for auditing tasks for quality for Terminal Bench 2, is we created an agent whose job it was just to cheat. And we told it to go look at the task, try to anticipate what the tests that we're going to execute might be, and then come up with a way of solving the problem that takes advantage of the characteristics of the environment. And so like an example of this is there was this issue identified with SweBench that impacted a small handful of their problems recently, where the full Git history of the repo was still available in each of the SweBench problems. And so agents could actually solve the task by peeking ahead in the Git history to the point where the issue was actually solved, and then just implementing that patch. And to the SweBench team's credit, like they patched this, they identified it. It only impacted a very small number of problems in that benchmark. But we actually saw our cheating agent do that, you know? And so like, I do think it's important to evaluate adversarial models in these benchmarks generally.
Cool. Next question is from Niall. Niall, do you want to unmute and ask the question?
Sure. Yeah, great presentation. I had a question on why, like, what comes next. So, like, you kind of touched on this in the talk that this terminal tool are very suited towards models because they have a small context, like, and it's all text, and so it's like kind of playing into the strengths. Like, what do you think comes after when they reach a high enough like percentage of these tasks that are able to be done by agents? Like, what's the next frontier of, I guess, like environments afterwards?
So I guess like, particularly when we started this project, as I mentioned, there was kind of this tension about what computer use would look like. And you saw these great projects come out where the model was actually trying to navigate a GUI to solve a problem. And they, even at the time, they could do this pretty well. I don't think that this is what like the majority of computer use is going to look like for the reasons that I tried to get to on this slide. I don't think it makes sense to have a language model navigate a GUI that was designed for a human. I think for many tasks, they're always going to be more performant if they're writing code or issuing bash commands. I think something too, like, if I could do one thing differently about Terminal Bench, it would be to think more carefully about the name and what we were trying to imply. So our agent, Terminus, interacts with Terminal Bench through a headless terminal. It just issues bash commands. That's all it does. But many of the other agents that we evaluate on Terminal Bench have these bespoke tools built into them. So like Claude Code has a file editing tool that it will use sometimes to edit files instead of using sed or cat or trying to use nano or vim. And these work well. Like these are probably responsible for some portion of the improvement that you see with these models. But like really any form of agent could be evaluated on Terminal Bench. Like really, if I could do it again, we would probably call it something like Container Bench or Environment Bench, because we are somewhat opinionated about the terminal being the best interface to solve these problems, or terminal-like interface being the best way to solve these problems. But just practically speaking, there's all sorts of ways to do this. About the future of environments, I do think that there's a lot to be mined here. Like all we're doing fundamentally is giving the agent a Docker container, and then we're letting it do whatever it needs to do inside there. And you can abstract all kinds of super long horizon tasks into this framework. Um, like really anything that can be done on a computer could be specified as a terminal bench task. So I think that there's a lot to be gained there. I mean, as I said, like the real future of evals is likely going to be deploying these models into real environments and seeing where they fall apart. And we'll also see the complexity of these environments build. So something that's been really cool has been in the time since terminal bench is released is like there's kind of this cottage industry that's popped up in San Francisco of people building environments and selling them to the frontier labs for training. You know, there's startups doing this like Mechanize and Bespoke, but then there's also just like guys in their apartments building a Salesforce clone and then selling that to Anthropic. And they're doing that like both for evals like this, which could be hosted inside of a terminal bench type task, or for RL training. One thing I'll say is like I think an open question is whether these environments are going to be very narrow or very broad. Like if you're training a model or you're doing evaluation and you have a limited amount of money to spend on creating your environments, does it make more sense to have 10,000 relatively shallow environments like we have in terminal bench? Or does it make sense to just have like one Salesforce, you know, and that's where you're doing your evals and that's where you're doing your training. And that's something that we're hoping to answer with our DC agent project.
Awesome. I see a question from an anonymous participant. So maybe I'll just ask that on their behalf. The question is, when I'm coding with an LLM assistant, I notice that it sometimes takes a very convoluted approach to a rather simple problem. Are there tests or evals to see if the LLM takes this simpler approach, if there are multiple ways to solve the problem?
It's very hard to evaluate the process of an agent. And so it's something that we don't touch in terminal bench. And this is because like you can evaluate the end state, you know when to run your tests, you know like what you'd expect the final environment to look like. Is this bug patched? Does this service work as I asked it to? But we don't touch any of the intermediate steps. So we like really give the agent a very long leash to try to solve problems. I know there's a lot of interest in a benchmark like this. You know, like one thing the Claude Code team told us was that they'd love to have a benchmark for taste. You know, like is this solution actually one that a human would merge into a PR? And so, you know, maybe someone can go out and build something like that. I know there's projects that are like a LM Arena for LM Arena for Code. Valerie, one of the contributors to the project, is a PhD student at CMU and has been doing some great work along these lines. But I think this is like an open question.
That makes sense. Okay, cool. I think I'm gonna hand it over to Abby to conclude this sort of this section of the Q&A. And then I think we'll have like informal Q&A to the extent that Mike can stay on and answer questions. So yeah, Abby, take it away.
For sure, yeah. So first off, thank you, Mike, for sharing more about your work and your thoughts on the future of evaluations. It was an awesome presentation. And if anyone in the audience is interested in learning more about Terminal Bench, I'll be sure to share a link in the chat with the website. And thank you to Raj for helping us logistically get all of this coordinated. It's been awesome working with you and the alphaXiv team. Just for what we have in store for the future of these discussions, we're hosting our next one with John Yang at the same time next week, where he will share his work on evaluations and training paradigms for software engineering agents. And I'll share that Luma in the chat as well. Lastly, we'll post the recording to the alphaXiv community YouTube and share a link in our community. And if you're interested in continuing the conversation or want a link to that recording, please join our AI Evals alphaXiv community, also linked in the chat. Yeah, with that, those were the little bit of the words I wanted to say. Thank you guys again for coming, and I'll share those links in the chat now. Nikhil, I'll pass it back over to you. Oh,
I just say John's great. He's given a lot of great feedback on this project, and I definitely recommend catching his talk next week. I'll probably be there.
Fantastic.